Hi everyone, my name's Aaron. I'm the primary author of SQLBoiler, and today I'm going to show you how to get started with version 3. So before we get started on how to actually use SQLBoiler, I wanted to take a short moment to tell you why we created it and why it might be useful for you. So you can read more in detail on this on the Why Another ORM section on our README, but in short, we really wanted to work with existing databases. Most of the other ORMs that were around the time when we created SQLBoiler, they really wanted to define the query. And we don't think that's, or rather define the schema. We don't really think that's possible because you have to invent a Go sublanguage with struct tags or what have you to be able to mimic the features in your database in Postgres and MySQL. And it's simply not possible to create a sublanguage that can deal with all of the different things that you can do with straight SQL. The next thing is we really wanted active record-like productivity. Now we came from Rails, and when we came to Go, for the reasons many people come to Go, we realized that the ORM and just dealing with databases in general in Go was rather unpleasant. We really missed active record, which basically worked hard to make it seem like you weren't using SQL or even a database. You were just interacting with objects in your Ruby program. We really liked that. And so we tried to bring that to Go, and I think we've done a pretty good job. However, at the same time, we really wanted to maintain a Go-like feel. If it didn't feel like we were writing Go, if it felt like we were writing Ruby or something else, then there's no point to it. It has to feel like we're just dealing with regular Go structs and just regular functions. Otherwise, it wouldn't be as good. And I think we delivered here too. The final thing is we needed Go-like performance. One of the main reasons we came from Rails was because of performance. And so we wanted SQLBoiler to perform very well. And if you take a look at the benchmarks, we do very, very well against anyone in this category when it comes to binding or doing queries, any of this, we compare very favorably. So let's get started. We're going to take a look at our schema that we're going to be dealing with. We've got users, videos, and tags videos. This is somewhat a schema of a YouTube clone. We also have some data that we're populating at the bottom here. Notice that we've named our foreign keys user underscore ID, very much table name underscore ID. This helps SQLBoiler generate nicer names for our relationships when we actually go to use them. The next step here is to create the database that we're going to be using, as well as the database user, and load the data into that database. So here I create a user named Start, his password is also Start, and I create a database called Getting Started. Now we're going to load the data into the database. You can see all the inserts, all of our data is inserted, and we're ready to go with our database. Now it's time to install SQLBoiler. Because the master branch is not v3 right now, and I'm trying to show you v3, I actually have to clone and install SQLBoiler manually into my Go path. And because we clone manually, we also don't have any of the dependencies for it. So we're going to do a go get in SQLBoiler, as well as a go get in the SQLBoiler driver. And I'm showing here that we do have things in our path as well. And you can see SQLBoiler PSQL is now in our path as well. So we're ready to go. So we're going to create our project directory now. So I'll put that under my GitHub username. And we'll start up our editor. So here we're going to delete some of the templated stuff that came from my editor. We're going to import the libpq driver. This is the actual database SQL driver, not an SQLBoiler driver. We're also going to add this go generate line, which is going to call SQLBoiler wipe PSQL when we type go generate. This is just an easy way so we don't have to remember what our arguments are. Here I'm configuring SQLBoiler with sqlboiler.toml, and I put in the username, password, start, host, localhost, and the database name. When we type go generate, it'll run that statement that we put in our go generate statement before. Now we're going to open the user model, and you'll see that the user's model really isn't that ugly. ID name, it has some struct tags to help us with serialization, but it also has this R and L. This is the ugliest part of an SQLBoiler struct, but I think you'll grow to like them if you figure out what features that these allow us to create. You can also see below there's user columns, and these are just static constants for you to use in place of column names while you're using SQLBoiler. Now we'll go back to main.go and we're actually going to get a couple different packages, and these are dependencies for the generated tests. When you generate from SQLBoiler, it creates tests, and we can use these to test our models to make sure that we're compatible with SQLBoiler. You see here I've run my tests after getting those dependencies, and everything passes. So now we're going to use a regular SQL open call. This is the same one that you'd use if you weren't using SQLBoiler, and it's part of SQLBoiler's charm. I'm going to make kind of an ugly helper here called die-if, and it's just going to be so I don't have to handle my errors explicitly or as explicitly. You should know better than to create a function like this. So we'll just add a little bit of extra stuff to make sure that we know that we're connected to the database. When we run this, we'll just see the word connected, and we're ready to go. So the first thing we're going to do is create a user. We're going to create a normal user struct. It's just a struct that we saw earlier, so we can just use the name as if it was any other struct in Go. We're going to give him the name John, and now we're going to insert him into the database by calling u.insert. Notice the boil.infer here. This means infer the columns that I should be inserting. And it's just a combination of rules that tells us primary keys, if they have a default value, don't insert those. Don't insert default values that are not 0 valued. So it basically tries to intelligently guess which columns you actually want to insert into the database and what it should be binding back into the struct as a default value. These default values are then available inside the struct, so I can say u.id and I get the correct ID out. So now we're just going to print out the user's ID. The reason we do this is just to illustrate the fact that when we run this program, we're actually going to see user ID 3. Remember, our schema already had 2 users, and this is the 3rd user that's been inserted. Now we're actually going to query the database for a user. We're going to say .1 here. The .1 is going to do a limit 1 query, so we only get 1 user back. And of course, we're not asking for a specific user, so it's just going to be the first one that happens to come back from the database. So there you go. We see user ID 4, we see got user 1. The ID is 1 because it's just getting that non-particular user. But what happens if we want to get a particular user? Here we can use the find user helper. This find user helper finds a particular user based on his ID. We'll output him just so that we see that we've got the correct user back. And there you go. We have found user 5, and our inserted user ID was also 5. Next, we're actually going to update this user. We'll see how to perform an update. So we pass in the context our database handle just like before, and we actually say boil.whitelist this time. And the whitelist is going to tell us exactly which columns we want to insert. And instead of using name here, I can actually use a constant that's defined in SQLBoiler's models package for this instead. This is just a little cleaner, and if the table name or column name ever changes on me, my code will break, so I'll know that there's a change that I have to deal with. You can see here that we also have rows affected coming back, so we're just going to output the number of rows that were affected by this query. When we run this program, we can see we have user ID 6, we found user ID 6, and we updated 1 users, which would have been the user ID 6. Next, we're actually going to see how we can use query mods to make a more specific query for a particular user. Now in this case, we're just going to say where name equals question mark, that's our placeholder, and found.name. So we're looking for Jane in the database. We're going to say .1, which also limits our query to 1, and we're going to pass in our context and database. We'll do our error handling and output that we found the updated user. And you see in the output that we have ID 6 and it is updated to Jane. We don't see ID 7 because again, it's just getting the first user where name equals Jane, and there's now 2 users that equal Jane since we've run this twice. Now we're just going to demonstrate a helper, user exists. There's also an exists finisher that you can use on any query. In particular, we're curious if this one user exists. So we're just going to show the user found again.id, and you can see user 6 exists, true. So we were able to find that user in the database. Next, we're going to try a count query. So the count finisher actually takes the query that's been constructed and adds a select count to it so that we can get a number back for how many users there are, or how many users where deleted equals true are. And you can see in this particular instance, there's 9 users in the database because every time we run this program, we're adding yet another user. The next thing we'd like to show is how easy it is to get the videos for this particular user. This is using one of the relationship helpers. And you can see it's as simple as saying the user.videos. And we're just going to output the number of videos that we got back here. We're going to for loop through these videos as well and just output their IDs, just so we can see that they exist. The support for relationships in SQLBoiler goes a lot deeper than this. I'm going to make a follow-up video called Advanced Queries and Relationships that you can watch if you're still interested after you've seen this video. Take a look over there because it's going to show a lot more of what SQLBoiler is capable of. And that's all I've got today. I hope I showed you how easy it is to use SQLBoiler, how easy it is to get started with SQLBoiler from even an existing database, and I hope you continue to boil your databases.